Okay, now let's see this question. This is a 2015 question, and the question is, consider the following operations, and f of xyz and g of xyz both are given. We are asked that which of them is functionally complete. Okay, so what is functionally complete? uh, okay, so functionally complete means that using that operation, so in terms of f and g, can we somehow get uh, all the other expressions which can be derived from such expressions, and something like that is only possible when, so for I'll give you an example. So let's say if I can find not, I can find and I can find or, then turns out that I can express anything. So sum of product of sum, you might have heard. So everything can be expressed if I can somehow get all these three. Turns out that since I have De Morgan's rule, so something like this, when we are talking about like a or b, let's say I'm talking about just is or not, and only these two are functionally complete or not. Is everything can be expressed or not, can everything be expressed using just these two? Turns out it is. Why? Because say if we are having a or b, something like this, okay, what I can do, I can take apply De Morgan's rule. So I can apply two times not. Okay, the first not is, let's say, outside, and then inside I am going to have not a and not b, right? So now you can see that, see, not and then and. So only using and not I have been able to express or, which means that only these two are sufficient, and that's what the definition of functionally complete is. Similarly, it turns out that only these two are also sufficient. So if somehow you can find not and then also it is functionally complete, or somehow you can find not and or, then also you will find that it is functionally complete. Anything you can do, but these two must be there, which means that if x, let's say, is there, then I should be able to find not x. First thing is this, and second thing, let's go with this definition. Then second thing I am saying is that if x and y, two things are there, then somehow we should be able to find x and y. If I can do this, then that thing is functionally complete. My point is that if I can be able to do that using f, then f is functionally complete. If I can do that using g, then g is functionally complete. And that is what they are asking, that which of them or r is functionally complete. Okay, so let's start with f, the first one. So is there a way using f I can get not x? So let's say f is there. What if I pass everywhere, instead of x, y, z, everywhere I pass x? So x, x, x. If I do something like that, then what I'm going to get is that not x, and then x into x plus x into x prime, which is not of x, and plus x prime and x prime, right? Okay, so you can see that it has x in x and not x, which is false, and this is false. This entire thing becomes false and false, and this is the same element, so it will be simply x prime. Essentially it is x prime. So if I pass something like this, then I get x prime, which means that I am able to get not x from x. Okay, now can I get x into y? Let's try with something this. So something like this, let x prime as first argument, x prime as second argument, and then y prime as third argument. So here what I'm doing is that, okay, I have x, I have y. I know how to find not of x and not of y, I know that. So not of x and not of y I have found, but in the function I'm passing not of x as first and second arguments and not of y as the third argument, which I can compute as the first part mentioned. And now let's see what is this second part. So here I can say that as per the definition, it is going to be x, so x prime of prime, which is x, and then yz. So essentially it is x prime y prime, and then it will be x prime and x, and then it will be xy. Okay, so y prime z prime and then xy prime. Okay, so x and y prime. Okay, so this thing is which we are getting. Now again you are saying that okay, this thing is going to be false, this thing is going to be false. Okay, x and x prime, which it can never happen. So basically it is false or xy, and essentially it is meaning that it is xy, which turns us to the fact that if I have started with x and y, if we do something like that and then pass these things, then finally we are able to get xy also. So definitely f is functionally complete. Okay, that is okay, but what about g? So we will start and try to figure out that is it possible that whatever way in which we have tried to see that f is functionally complete, is it possible that g is also functionally complete in that same way? So what we will do is that I will tell you in advance that basically G is not functionally complete, and rather than trying to create not x and not and x into y from G, I will just try to show you that you cannot find something like x and y, not x or x into y, something like that. That is not possible, because I am simply going to simplify this expression of G, and then you will see that G of xyz is what? So let's write it simply. It is x prime yz, and then it is x prime yz prime, and then it is xy. Okay, so let's try to solve it. So x prime and y, this thing is common, right? So I can take x prime y, and then I can have z or z prime. Now if I have z or z prime, it simply means that this thing is true, right? And plus xy is there, and true is multiplied with anything, then definitely it is simply that thing only. So x prime y plus xy. Now what can I can take common? I can take common y, and then it will be x prime plus x, and then y is common, and then I can see that again this thing is true. X or x prime, it is always true. So this true into y is y. Turns out that everything, this entire expression is basically just y, which means that this g is basically discarding this and simply returning the middle element, just middle element as it is returning. So there's no way that you can find a not of any element, or let alone and of any element, or of any element, right? So it is not possible, and that's why we have shown that G is not functionally complete. So our answer is going to be B, that only F is functionally complete. The answer is B.